So happy Monday. We're going to start with section 2.6 logarithmic function. So last time we talked about exponential functions. So logarithmic and exponential functions, they are inverse functions to each other. What that means is they're opposite operations. They cancel each other. The same way like x squared and square root. So if you have square and square root, they're opposite operations. They kind of cancel each other. Okay, so the same way exponent and logarithm, they're inverse function to each other. Okay, and this is how the logarithmic function looks like. So if you have function f of x equals logarithm with base a of x. You can put x in parentheses or no parentheses, doesn't matter. Okay, so the a is the base, the number in the little down, it's the base, called the base, and x is the exponent. Now compare, let me just write one more time the exponential function. So exponential function is function and you have number with exponent x. Now you already know what is number with exponent, right? You know what is 2 to the fourth. 2 to the fourth means multiply 2 4 times by itself here, right? Now, you don't know what is logarithm, so let me explain the logarithmic function. And you have it here, the logarithmic and exponential function. So the logarithmic function gives you what is the exponent for the base to get x. So this is what you have. So this is what that means. Logarithm with base a of x here means a with what exponent is x. So if I look at this, let me give you an example. So if I want to find what is logarithm with base 2 of 8, that means this logarithm means how many times you multiply 2 to get 8. So that means what is 2 with what exponent is 8. Okay? So logarithm with base 2 of 8 means how many times you multiply 2 or what is the exponent for 2 to get 8. So how many times you multiply 2 to get 8? How many times?
4.
2 times, no, not 4. 2 times 2 times 2 times 2, that's what you're saying is 8?
3.
3 times, that's correct. 3 times. 2 times 2 times 2 is 8. So the exponent here for 2 is going to be 3, which means logarithm with base 2 of 8 is going to be 3. So the logarithm technically gives me what is the exponent for the base to get that number there, okay? So the base of the logarithm, I mean, I'll show you how to do it in the calculator. You don't have to do it in your head all the time. You can do it in the calculator just to understand what is the meaning of logarithm. So the logarithm is a function which gives me the exponent for the base to get the number in the logarithm, okay? So here what you have is, we're going to do some properties. And these properties are going to help us with, the properties are going to help us to solve equations with logarithms. So these are the basic operations we're going to do with logarithms, okay? So first of one is when you have equation with logarithms, so if you have given something like this, you're going to solve it when you change it to exponent. How you change it to exponent? You're doing something like a circle. So this is what you're doing. You're going to write the base first, then with exponent y equals x, okay? Or you can say x equals a with exponent. So remember, always the number below, it's a base. So a is gonna be, see, a is always the base. It's a little below. So a has always something in top of it, okay? And let's do some example to see how that works actually. So if I look logarithm with base 5 of x equals 3, We're going to solve this equation when you switch it. So you're going to have x equals, and you're going to do 5 with exponent 3, right? So that's what x is going to be equal. So you have x equals 5 with exponent 3. What is 5 cubed? 5 times 5 times 5, right? I'm going to rewrite it so you can have it, break down what that means. And when you multiply those, you're going to get is 125. So that's it. X equals 125. Any questions? So switching logarithm to exponent is the way to solve equation with logarithm. Let's do the next one. So the next example we have is number 2. And here we're going to have x plus 3 equals what? Can you guess what is that equal? X plus 3 equals what? 4 with exponent 3. That's right. So x plus 3, so you look at this like one piece because it's in parentheses. X plus 3 equals 4 cubed. Now you have to do what is 4 cubed? 4 times 4 times 4, right? Which is 16. 16 times 4 is what? 64, right? And then from here, we're going to just solve it. We have x plus 3 equals 64. And what you do to solve it? You're going to subtract 3. And you're going to get x equals 61. That's it. Everybody understanding that? Any questions? No? Everybody good with this so far? Okay, let's go ahead and do some more then. We're going to go ahead and do the next one, number 4. So number 4, we're going to use some of the properties for number 4. So that was the first property. When you have logarithm equals number, you're going to change it to exponent and solve it. The second properties we're going to talk about, so these are the other properties, which are going to help us to solve it. The first one is, if you have log plus log, that's log of multiplication. It's similar like product property for exponent. So if you have log plus log equals log of multiplication, log minus log is log of division, you divide. And then here, if you have exponent, you're gonna move. See, if you have log with exponent, this exponent is gonna move in front. So you're multiplying n times logarithm. So these three properties are similar like what you have with what we had before with exponents. So they're similar. So if you have add, log plus log, you do multiply them. If you subtract, you divide them. If you have exponent, you multiply by, okay? And also I'm gonna write another property, which is the one you're gonna use in number 3 and number 4. It's kind of breakdown from the last property here from exponent, but then I have additional something to put. So I'm going to just write it like this. If I have logarithm with base a, and then you have a with exponent n, see this here cancel, so the answer is just n. I'm going to show what cancel. And I can break it down. So this here is 1 technically. Log with base a of a is 1. 1 times n is n. Okay, so that's how you do it. And I can just write some logarithm here. So very common use logs. I'm going to delete this. You understand what is logarithm means, right? Very common use logs. I'm going to write it here. This, if I have logarithm with base a of a, that's 1. So if you have base and the arguments are the same, it's 1. And if you have logarithm with base a of 1, this is 0, which means a to the power 0 is 1. Okay? So this is also the logarithms you're using. So now let's continue solving these equations. So here I told you you're gonna cancel this log 3 of 3 is 1. So the answer here is 8 equals, so only 8 is left. 7 plus 3x. And then you're solving this equation when you subtract 7 in both sides. And you're gonna get 1 equals 3x. Then you're gonna divide both sides by 3. And that will give me x equals 1 over 3. Okay, any questions? Okay, let's do the next one the same way. So logarithm with base 2 of 2 kind of cancel out. And you have 6 left. Equals 4 minus 3x. And you're solving it when you subtract 4 in both sides. 4 cancels, so I have 2 equals negative 3x. I'm going to divide by negative 3 both sides. And that will give me x equals negative 2/3. Just leave it like as a fraction. Okay, so that's how you do this type of logarithms. Okay, any questions so far? Okay, going to the next one. Yes?
No, I was just saying no question.
Okay, thank you. So the next one, we're going to do the same way. We're going to switch logarithm to exponent. Now, you see that ln? So if you see ln, or if you see logarithm with no base, like number 11 have no base, see, log and x minus 1, there's no base, right? So these are two specific logs which are very common use logs. So the first common used log is when you have ln. So if you have ln of x, only ln, you know that you should know that the base here is logarithm with base e of x. So if the base is e, which was the Euler number, remember e is about 2.7. We talk about the number e, irrational number like pi, and e it's about 2.7. So if the base is e, and the number is used in science a lot, so it's very common use logarithm. So if you have logarithm with base e, then you're going to see ln. And this logarithm is called natural log. Okay? And another very common use log, remember we talk about base 10 in engineering, they use it base 10. So if the base is 10, you're not going to see it. It's going to be just logarithm of x, no base. So if there is no base, you should know that the base is 10. Okay? So if there's no base, you know the base should be 10. And this logarithm, it's very common use. It's called common log. Okay, it's called common logarithm. So natural logarithm and common logarithm, they used in science and engineering. And these two logs used to be in the old calculators. So the old calculators, they have only those two logs. But now we have better calculators and they can calculate logarithm with any base. And I'll show you the calculations in a little bit, okay? How to do the logarithm in the calculator. So knowing that, let's go ahead and do number 5. So number 5, we know that the base is e, correct? Because it's ln. If it's ln, the base is e. So we're gonna switch it. So I have e to the 8. So I'm gonna write x plus 5 equals e to the 8, right? Now e to the 8, it's a decimal number, so I'm just gonna keep it as like the way it is. And we're gonna just keep it like e to the 8. So in order to get x by itself, I have to subtract 5 in both sides. So these cancel, and you're going to get x equals e to the 8 minus 5. And this is how you can leave the answer in exact form, if they want you to leave it in exact form. If it says round, that's exactly what it says here, right? If you go back, it says evaluate to 4 decimal places, right? It says here. So this one, we're gonna put it in the calculator and we're gonna evaluate it. We're gonna get to 4 decimal places. So I'm gonna get answer here, gonna get another answer, which is x equals, it depends how they want it. We're gonna round it. So in the calculator, we're gonna put e to the 8 minus 5. So going to symbol up, that's the calculator we're gonna use. I'm gonna put e, just press E in the keyboard, e with exponent 8 minus 5. That's what you get, right? 5, yes. Okay, so we got, this is the decimal form. Everybody see that? So if I want to round this to 4 decimal places, I'm gonna look at the 5th number and I'm gonna round it to how? So it's gonna be 2,975 point, when I add 1 to the 9, because 8 is bigger than 5, so that's gonna be 79. When I add 1, it's gonna be 80, right? So it's gonna be 0.9580. Now this 0 in the end is kind of insignificant, so you don't have to put the 0 in the end. Okay, so I'm gonna just copy that in my answer. So my answer here, it's, let me draw, is gonna be 2,975.95 and 8. Okay, so everybody understand that? So that's how you round your number. So depends how they want you to do it in your homework. If they say leave it as exact, you're gonna do the first one, e to the 8 minus 5. If they want decimal, then you're gonna put it in the calculator and round it. Okay? So that's how you do this one. Then you're gonna go ahead and do number 6, where we're gonna do the same. We're gonna change logarithm to exponent. So we have this here, which is x plus 2, x plus 20 equals, the base is x, and it's gonna turn to exponent 2, right? And then this is quadratic, so I have to subtract everything, move it in the same side, so it's gonna be minus x and minus 20. So the equation become x squared minus x minus 20 equals 0. Okay, and then you're gonna factor this, so it's gonna be x minus 5 and x minus plus 4, because we have negative 5 times 4 is negative 20, and negative 5 plus 4 is negative 1. And then from here, gonna solve this 0 and this 0. So that's gonna give me 5 and negative 4. And these are my two answers. So we're gonna get 5 and negative 4. Now, I wanna explain something very, very important here. Now, those two answers, see, the original equation have logarithm. So all the equations before, you should do that, but here I see the need to explain it. So when you solve equation logarithm, the original equation have logarithm, it's very important that you check your answer, because the definition of logarithm is the argument have to be positive. This is what is important. I'm going to show you here. So talking about the exponential function and the logarithmic function, the base here, it says is positive. So this is important. The base have to be positive. Sorry. So the base have to be positive. Okay. And also, it doesn't do it the way I want it, so I'm going to leave it like that. So the base is positive, is very important. And also x have to be positive. If you have logarithm of base a of x, this x have to be greater than 0. It's very important that x is greater than 0. Okay? It's very, very important. The x logarithm of negative doesn't exist. Okay? So keep that in mind. So when you solve equation with logarithms, over here, up a little up. So when you solve equation with logarithms, x plus 20, only x plus 20, has to be positive. Okay? So when I get my x's here, 5 and negative 4, I have to check it. I have to check your work. And what you check? You're going to check, I don't know why it's not doing this. I'm going to do a trick here. So how you check it? We're going to check if this is what you're checking. You're going to take 5, you're going to plug it in x plus 20. And if it's positive, we're good. If it's negative, it's not a solution. Okay? So sometimes whatever you get for x, it's possible to be not a solution. So this is how you check it. So you take 5 and you do 5 plus 20. You replace x with the number you get. We have 5 plus 20 is 25. Is greater than 0. So that means 5 is good. Okay? Then you're going to replace x with negative 4. So you have negative 4 plus 20 is 16, right? Which is also a positive number. So that means negative 4 is also a solution. Now, if one of those numbers is not making the inside the logarithm positive, then it's not a solution. Everybody understand that? Yes, maybe?
Yes, ma'am.
Okay, so always if you have equation with logarithm, just keep in mind you have to check it, okay? So let's go ahead and especially, I mean, you always kind of look at what you're going to get to make sure it's not negative. So let's go ahead and continue with number 7. So number 7 and 8, they are different type of equations, which is kind of shortcut. And this is what you're going to use here. We're going to use logarithm equals logarithm. So when you have logarithm equals logarithm and see the bases are the same, you're just going to cross them out the same way we did with exponents. Remember, if you have exponent equal exponent, the same basis, you cross them out. So the same way here, we're going to cross out this logarithm, and you're going to solve only this equals this. Okay, so this is kind of easier to do. So we're going to solve 4x plus 3 equals 6x minus 5. And then you're going to subtract 4x. We're going to move the x's in the right side. And you're also going to, I'm going to add 5 to move numbers in the left side. So what you get? 3 minus 5, oh, sorry, you're adding 5. 3 plus 5 is 8 equals 2x. Then you're going to divide by 2. And you're going to get x equals 4. Now, you can do quick check here. When I replace x with 4, I mean, this one obviously is, or I can just do it here real quick. So I'm going to plug it in both of those. So I have 4 times 4 plus 3. It's positive, obviously, right? And the other one the same way. 6 times 4 minus 5 is also a positive number, right? 24 minus 5 is positive. Okay, that's all what you need. You need to double check if the numbers you get are positive. So that means the number 4 is a solution for my equation. Everybody understand that? So always check. Okay, then you're going to head and do the next one. So let's do number 8. For number 8, we have again logarithm equals logarithm. We're going to cross the logarithm. So we're going to solve 8 minus 5x equals 2x minus 13. I'm going to add 5x in both sides. And I'm going to add 13 also. So we have 13. What we have? We have 13 plus 8, 21, right? 7x divided by 7. So get x equals 3. Now x equals 3, let's double check. So I'm going to plug it into the first one. So we have 8 minus 5 times 3. 8 minus 15 is negative, right? Yes? So if you get negative number, that means x equals 3 is not a solution. And because it's only one solution, then the solution for the whole equation is going to be, see, I don't need to check the other one. If one of them is negative, that's enough to say that it's not a solution. Got it? So the answer here is no solution. This equation have no solution, which is okay. It happens sometimes. Okay? Everybody good with this explanation? Any questions? Okay, let's go ahead and do the next one. So the next one, the next equations here, number 9 and number 10, 11 and 12 also. We're going to use the property for sum and difference of logarithm. So that was if you have ln plus ln or ln minus ln, log plus log, it depends what is the base, doesn't matter. So the rule is if it's plus, become multiplication. If it's minus, is division. Okay, so that's what you're going to keep in mind. So let's do number 9. So we have ln plus ln, so it's going to be ln of multiplication, so multiplying x and 8. So it's going to be 8x equals 5. And then from here, we know that the base for ln is z, right? So I'm going to switch it. So it's going to be 8x equals e to the power 5th. Then you're going to divide it by 8. And you're going to get x equals e to the 5th over 8. Now, obviously, this is positive number. And how I know it's positive? Because e is positive. And when I raise it to power, it's going to be positive. And when I divide it by 8, it's going to be positive, right? If I want to get the exact number, I mean, this is the exact number. If I want to get the decimal number, so if I want to round this number, I can just put it in the calculator. And I'm going to put it here, e to the 5th divided by 8. Divided by 8. Oops, sorry. I guess I need to put this first. I need to press exponent first, fractions, and then use exponent. Like that. And let's get the decimal. Okay, so it's 18 point, remember 4 decimals, 4 numbers, so it's going to be 18.5516. And why is only 16? Because after 6 is 4, which is less than 5. So this is my round number by 4 decimal places. Okay, so you can have this number or that number, depends how they want the answer to be written. Okay, then you're going to go ahead and do the next one, which is number 10, the same way. We have ln minus ln is going to be ln of division. So we're going to get ln of x over 2 equals e to the 0, right? I'm sorry, let's, hold on. Equals 0. I'm skipping steps. Okay, ln of x over 2 equals 0. And then here we're going to switch it. We're going to write x over 2. Remember the base is e to the power 0. So we're going to get x over 2 equals e to the 0. What is e to the 0? 1, right? Anything with power 0 is 1. So I have x over 2 equals 1. So in order to solve it, you're going to multiply both sides by 2 to cancel the 2, and you're going to get x equals 2. And x is already positive, so when I plug it in, it's going to be positive. So that's my answer. And it's a whole number, so you don't need to go and plug it into the calculator. Okay? Then let's go ahead and do the next two the same way. So I have log minus log. So the base is 10, and it's going to be log of division because it's a minus. So if it's minus, you're going to divide. So it's going to be logarithm of x minus 1 over 4. You're going to divide, equals 3. Then you're going to switch it. So it's going to be x minus 1 over 4 equals, now the base is 10, and it's going to be to the power 3. What is 10 to the 3? That's 1,000. And also I'm going to multiply both sides by 4 to cancel the denominator. So I'm going to get x minus 1 equals, now 4 times 1,000 is 4,000. And then I'm going to add 1. And that's going to be my answer, but I need to double check, right? So x equals 4,001. Now 4,001 is positive by itself, but I have to plug it in as x minus 1. So how I plug it in? Replace x with 4,001 minus 1, it's positive, right? So we're good. This is my answer. Okay? Then let's go ahead and do the next one where we're gonna do the same. ln minus ln is ln of division. Minus means division. Plus means multiplication. So I'm going to get ln of x minus 1 over 6 equals 2. And then you're going to switch it. ln, the base is e. So it's going to be e squared. So we're going to write x minus 1 over 6 equals e squared. Then you can multiply both sides by 6. So 6 and 6 cancel. So I get x minus 1 equals 6 e squared. And then you're going to add 1 in both sides. And it's going to be x equals 6 e squared plus 1. And this is my exact solution. If they want the exact solution, that's it. If they want me to round it, I'm going to put it in the calculator. So it's 6 e squared plus 1. Let's go ahead. Oh, sorry. Let's go ahead and plug that in. So we have 6 e, what was that? 6e squared plus 1. E squared plus 1. And we're going to get, it's going to be positive, obviously, 45.3343, because after the 43 is another 3, which is smaller. So it's going to be 45. And then what is it? 3343. Now, when I plug it in, it says x minus 1. So when I plug it in, it's going to be obviously positive number. So this is a good number. This is my solution. Okay, so that's how you do this. Any questions so far? So here we're going to continue with a different type of equations, which are equation with exponents where the bases are not the same. So when you solve original equation with logarithms, after you solve it, you're gonna check your answer, right? Like here we have logarithm, everything you solve with logarithms, the original equation, you have to check your answer. Now, when you solve original equation with exponents, you don't need to check your answer, okay? So this is how you solve, see, equation with exponent, but the bases are not the same. So you have base 3, base 14. So last time we solved equations like this when they have the same basis. Now 14, we can represent it with 3 with exponent. Like if 14 was 9, then you can write it 9 is 3 squared and you're going to make the same basis. But these bases are not the same. So in order to solve this type of equations, you have to change it to logarithm. And this is how you change it. So I'm going to write it like a rule. So if you have number with exponent equals another number, so a and b and x or something there. If you have something like this, you change it to logarithm. So in order to solve it, you're going to change it to logarithm. So I'm going to write logarithm. Now, which one is the base here? Which letter is the base? A, X, or B? Which one is the base?
A.
A. Good job. So this is the base A. So I'm going to write A. And then exponent is, this is going to be, and you're going to kind of switch it like this. So if the base is A, that's going to be the same base for logarithm. So it's going to be logarithm with base A. And then you're going to put B equals X. So that's how you switch it. So the base stays the base, okay? So when you change exponent to logarithm, you're going to solve the equation. You're going to get what x is equal. So in order to move the x from the exponent to down, you're going to change it to logarithm. So that's what you're doing here. You're going to write logarithm. You're changing it. So if I do 13, what is the base? 3, and then I'm going to do 14 equals 2x, right? Now, log with base 3 of 14, I can plug it in the calculator. Now the time to show you how to do that. And then I'm going to divide it by 2, both sides, to get x by itself. So now I need to put all this in the calculator. And this is how you do it. So I'm going to get x equals. In the calculator, I'm going to press fraction, 2 in the bottom. And I'm going to put logarithm with base 3 of 14. This logarithm base 3 of 14, it's a number, and I'm going to show you how to plug it into the calculator. Now, if they want the exact number, this is what's going to be the exact solution. But if they want it to round, and that's what they want, I just double check your homework. So you have to round it, and you're going to plug this in the calculator. And I'm going to show right now how to do logarithm with the calculator. So we're going to go to your symbol app. I'm going to start with fraction. In the top, I'm going to put this log. Everybody see that? Log with the base. So that's what you're going to press. So for fraction, this is what you press for fraction. For exponent, this one. And log with base is going to be this one. Okay? So I'm going to press log. And then the base was 3 and then 14. So I'm going to put 3. Then you're going to go to the next one. Is going to put 14, and everything is over 2, right? So I'm going to enter it exactly the way it is. Log with base 3 of 14 divided by 2. And then the calculator is going to simplify it, and it's going to give me the decimal. So this is my answer. Now, let's say you want to round to 3 decimal places. So it's going to be when around, let's say 3 decimal. is going to be 1.201. Okay, so that's how you round the logarithm. So it's going to be 1.201. Okay, any questions on plug it in into the calculator? Or any questions how to solve it?
No, ma'am.
No? And this is exponent, so you don't have to check your answer. So let's go ahead and do the next one. So number 14, we're going to do the same. We're going to change it. So we're going to write logarithm. Now, 7 is the base. And then you're going to put 19 equals this. So base 7 of 19 equals x minus 2. In order to get, so look at this logarithm with base 7 of 90. Look at this like one number. So if I want to get x by itself, what I need to do? I need to add 2 in both sides to get x by itself, right? So it's going to be x equals, I'm just going to copy everything, logarithm, just keep it like this. It's one number. And then plus 2 outside. Okay? And then you can plug that in the calculator and you're going to see what it is. So the way to plug it in is going to be just logarithm 7 logarithm of no z 7 of, what was that, 719 plus 2, and then you need to get out because it's outside plus 2, right? And then we're gonna get 3.513. I'm rounding 3 decimal again. 3.513. Okay, so that's how you do. So this is the rounding answer, and this is, oh, this is the exact solution. Okay, so any questions so far? So when you have logarithm equals number, that's what you're doing. I'm sorry, when you have exponent. Now the next one you have exponent, see you have exponent equal number. The next one you have base with exponent equals base with exponent. So this is a little different. We're gonna do something a little different. So what you're doing here, we're gonna take logarithm in both sides. Now it doesn't matter what base you're gonna take. You can take log with base 10, or I'm usually taking ln in both sides because there are only 2 letters, it's easy to write, ln. So I'm gonna do ln here and ln in this side. So when you do take ln, we're gonna use the property of exponent. So if I have ln, I'm gonna rewrite it. 7 with exponent x minus 1 equals ln 8 to the x. So when you have something like this, we're gonna use the property, we're gonna take this exponent, we're gonna move in front. This exponent is gonna move in front, okay? And then we're gonna distribute it from there. So it's gonna be x minus 1 multiplied by ln of 7 equals x times ln of 8. Now look at ln 7, ln of 8, it's a number. So if it's just a number, you're gonna multiply by x by 1. So you're gonna get x times ln of 7 minus 1 times ln of 7 equals x ln of 8. Now from here we're gonna get x and x in the same side. So this is one term with x and this is another term with x. So I'm gonna subtract x ln of 8 in both sides. And also I'm gonna add ln of 7 to move it over. So this cancel and this cancel, right? So what is left is we have x ln 7 minus x ln 8. Now, you can combine them because ln 7, ln 8 are different numbers, but what you can do, you can factor out x, both of those have x, and it's gonna be ln of 7 minus ln of 8 equals ln 7. And then in order to get x by itself, I have to get rid of this. So I'm going to divide both sides by ln of 7 minus ln of 8. Okay, both sides. So these cancel out, and you get x equals ln 7 over ln 7 minus 8. So this is my exact solution, this here. And I have to put it in the calculator to see what is the approximate solution. So I'm going to plug that into the calculator. So I have ln 7. So I'm going to delete this. I'm going to put fraction, and I do ln. So here we're just going to type it in, ln of 7 over ln 7 minus ln 8. Is that what you have? Yes. And then just enter it the way it is, type it in ln. And the decimal is going to be negative 14.573. Yeah, because after 7 is, after 2 is 6, which is going to be 3. Now, the answer we get, it's a negative number, right? Is that bother you, or it's okay?
I was just gonna say, I thought we couldn't have a negative answer.
Okay, yes, yes. Let me explain. Now, if the equation have logarithm in the beginning, then you need to check it. But this one, no need to check, okay? Because the original equation, see, this is the original, have no logarithms. So that's why it says, I'm gonna write no need to check. Because you can have any number into the exponent. But the only problem is when you have logarithm, the logarithm has to be positive, okay? So if you have exponent, you don't have to check it, okay? So my answer is negative, whatever you get, okay? So let's go ahead and do one more like this. So pretty much you're doing the same. You're gonna take ln in both sides, you're gonna bring down the exponents, and then you're gonna simplify, okay? So let's do that. So doing 16, and you can just finish everything in this page. So let's go ahead and do 16. So here we're going to do ln. I'm going to take ln in both sides. ln. So I'm going to start writing here ln of 4 2x plus 3 equals ln 5x minus 2. Now the exponents are all this is going to go in front, and all this is going to go in front of the ln, right? So we're going to get 2x plus 3 times ln x equals x minus 2 ln x. I'm sorry, ln 5 and 4. I don't know why I put x here. It's not x. It's 4 and this is 5. Okay? So we took ln in both sides, and then we moved the exponent in front. We have multiplication here, multiplication here. Now we're going to distribute. So we're going to distribute ln of 4 times 2x, ln of 4 times 3, and the same way with x and with negative 2, with ln 5. So we're multiplying. So when I multiply, I'm going to get 2x ln 4, and then plus 3 ln 4 equals, I'm going to multiply, so it's going to be x ln 5 minus 2 ln 5. Okay, now we're going to see which one of the x's, which one of the numbers. So this is x and this is x have to be in the same side. You have to move them in the same side. So I'm going to, let's say, subtract x ln 5 minus x ln 5. Cancel. And I'm going to subtract 3 ln 4. These cancel. So when you do that, you're going to get, now again, I'm going to factor x and x. Both of those have x's, so x in front. And I'm going to write 2ln 4 minus ln 5 equals, and I'm just going to bring that down, negative 2 ln 5. You don't combine ln 5, ln 4, just write it down. Minus 3 ln 4. They're going to go in the calculator, so just bring it down. Then you're going to divide both sides by 2 ln 4 minus ln 5. So divide two sides by 2 ln 4 minus ln 5. So when you do that, all these cancel, so you get x equals, now this is the exact solution. All this is the exact solution. Now I'm going to plug it into the calculator to see the approximate. They're going to ask you, I think, to get the decimal. So I'm going to plug it in, negative 2 ln 5. So it's going to be fraction again, big fraction. Negative 2 ln 4 minus ln 5. Is that right? Let me double check. Negative 2 minus 3 ln. So first one is 2 and 5, 3 and 4. Oops. 2 and 5. There's 3 and 4. Like that, right? Negative 2 ln 5 minus 3 ln 4. Or you know what? I can just write it down and then I can plug it in. Let's do that. That way I don't make mistake. 2 ln 5 minus 3 ln 4 over 2 ln 4 minus ln 5. So I'm just copying it in the screen, so when I switch windows, I'm still gonna see that. Negative 2 ln 5 minus 3 ln 4, 2 ln 4 minus ln 5. Okay, so I'm gonna plug that into my calculator. Let's double check. So negative 2 ln 5 minus 3 ln 4 over 2 ln 4 minus ln 5, like that. Okay, so you enter it exactly the way it is. And then you're going to get the decimal number. And I'm going to write it again so I can copy that easy. Okay, so the answer in decimal form is going to be, I need to round to, so it's negative 6.34290. So if I want 3 decimals, this is 9, so I'm going to add 1 to this, so it's going to be 0.343, right? Negative 6 point. So that's what you're going to get. So let's put the answer here. Negative, oh, sorry, let's change that. Now, it's a negative number, right? Correct? Negative 6.343. Okay, so that's my answer. Let's clear all the mess up on the top. So now, looking at my equation and looking at my answer, negative 6 point something. Is that possible? Is that okay? Do we need to check or not?
No, there's no log.
Yes, good job. Yes, there is no log in the original. No need to check. That's my answer. Okay? Got it? Okay, so we're going to have a few more to do the same way. So the first one is 7x plus 1. Exponent x plus 1 equals 10 2x. So we're going to take logarithm in both sides again. You can do ln if you want. Just pick what base you want to take. Doesn't matter. So I'm going to take ln. So I'm going to have ln of 7x plus 1 equals ln 10 2x. And then the exponents are going to go in front. So it's going to be x plus 1 times ln 7 equals 2x ln 10. Now we're going to distribute, so we're multiplying ln 7 times x and ln 7 times 1. So that will give me x ln 7 plus 1 ln 7 equals 2x ln 10. Now I'm going to look where I have the x's. So I have x here and x in here. So I'm going to move the x's together, and then the numbers already in the same side. So I'm just going to keep this ln 7 here. So I'm going to subtract x ln 7 in both sides. Cancel this. And I'm going to get ln 7 equals, now here we're going to factor out x, remember? So it's going to be x and then 2 ln of 10 minus ln of 7. And then here I need to divide by this to get only x by itself. So I need to divide by 2 ln of 10 minus ln of 7. And that's what I need to put in the calculator. So this cancel. And when I plug that into the calculator, I should get my decimal. So this is the exact solution. And when I plug it in, I'm going to get my approximation. So I'm going to get x equals something here. Okay, so let me put this also into the screen so I can have it. So I'm going to plug it in the calculator. ln of 7 divided by 2 ln of 10 minus ln of 7. So this is going to go to the calculator. And in the top, I'm going to just change the stuff here. So I'm going to have only ln of 7. And in the bottom, I have 2 ln of 10 minus ln of 7, like that. Okay? And the answer is, okay, we're going to round to, let's say, 3 decimal, 0.731 is going to change to 2. Okay, that's it. And my answer is 0.732. Okay, any questions so far? Okay, so that's how you do those. Now let's finish everything. Let's do all of those. We have time. Let's finish it. So we're going to change. We have exponent equals number. So here we're going to switch it around, right? So we're going to have the base. We're going to change it to logarithm, right? So we have logarithm. So we have x plus 2 equals logarithm with base e. If the base is e, is going to be ln of 34.896. So now we're going to get x by itself. So I just have to subtract 2 in both sides to give me x by itself. And my exact solution is going to be x equals ln of 34.896 minus 2. So this is what we need to plug it in into the calculator. If they ask you for the exact solution, this is the exact solution. But we're going to plug it in because usually they're going to ask you to round to a few decimal places. And this is what you need to plug into the calculator. So I'm going to copy this again so we can have it in the screen. So it's ln of 34.896 minus 2. So that's what we're going to plug it in. So in the calculator, we're going to delete all this and we have ln. So just type it in, ln 34.896 minus 2. Okay, that's it. And the answer is 1. We're going to round 3 decimal places, so it's going to be 1.552. After 2 is 3, so we're going to keep it like that. Okay, and then that's my answer here. 1.5, 5, and 2. Okay, any questions? Any questions so far? Okay, we have 2 more to go. And the last 2 questions, they're absolutely the same way. So looking at number 19, can you tell me what you're going to do for 19 to get x by itself? This is easy. What you're going to do? Now, can you do e squared? Do you know what is e squared? You can plug it in the calculator. You just e with exponent 2. And e squared is 7 point, see that? Okay, 7 point, I'm going to write it here. 389. Let's use them all. So if you do calculations before the final answer, make sure you use as many decimals as possible so you can get more precise answer. So we have x plus 7 equals 7.38905. Now, can you tell me what to do to get x by itself? Any ideas?
Subtract 7.
Okay, that's correct. Subtract 7. Good job. We're going to subtract 7 in both sides. And when you subtract 7, you're going to get only x. And it's going to be 0 point, right? 7 minus 7, the whole part is going to cancel. So it's going to be 0 point, and let's round 3 decimal again. 389. Now here you notice that I did calculations in the beginning in the calculator, but I use as many decimals possible, round on the end. In the end, you're going to round to 3 decimal. Okay, so keep that in mind, because if you round above, that could accumulate an error, and that's going to give you a wrong answer in the end. Okay, it could be like 1 digit off, but still, when you plug it in your homework, is going to be wrong. Okay, so just be careful. The best way to do it if you plug it in the end in the calculator. Okay, now let's look at the next one. We have number 20. We have e with exponent equals e with exponent. Any ideas how to solve this? E with exponent equals e with exponent. Just cross the bases, right? They're the same. So we're going to get 8x equals 32. Divide by 8. And you're going to get x equals 4. Okay, so I'm going to kind of review how to solve all the different type of equations. So when you have equation, when you have the same bases equal to each other, so if you have a with exponent equals a with exponent, another exponent, you cross out the bases and you solve it. X equals y, right? That's the first type of equation. The second type is when you have logarithm equals logarithm. So if you have logarithm base a of x equals logarithm base a of y. Log with base a equal log with base a, cross them out, and you solve x equals y, whatever is there. I'm just using x and y, okay? Now, if you don't have the same basis, then what you're doing, you're going to change it. So if you have exponent, like a with exponent x, so equals number. So when you have number with exponent equals number, then you're going to change it to logarithm. You're going to write logarithm to solve it. And in order to do that, it's going to be with base a of b equals x. Okay, that's how you solve it. Another type of equations we did is if you have logarithm equals number. So if you have logarithm with base a of x equals b, we're solving it when you change to exponent. So I'm going to write x equals a to the b, to the base b, to exponent b. Okay? And then the last type we solve, which when you have, let's say, a to the x equals b to the y. In this case, you take ln in both sides. So I'm going to take ln here and ln here. And you're going to move the x and the y in front. So x goes in front, y goes in front, right? Whatever is the exponent, I'm using x and y, and that's how you solve it, okay? So we're gonna get, I'm gonna write x ln of a equals y ln of b, okay? So that's, and you just solve it from here, solve for x. Okay, so these are the basic equations we solved today. We solve equation with exponents, equation with logarithms, and this is like a review how to do all of those type of equations. Okay, any questions? So this is what you have for today. Let me know if you guys have any questions.
No.
No, no.
No, everybody good? Okay.